Okay, so today we're going to learn how to construct a golden rectangle using the Fibonacci sequence. First, we need to review what the Fibonacci sequence is. So, the Fibonacci sequence is a series of numbers where the next number is found by adding the previous two numbers together. So, for example, if we wanted to get the number 2, we would add 1 plus 1, and 2 would be our answer. Another example is if we want to get the number 5, you add 2 plus 3, and you get 5. So that's how we construct the Fibonacci sequence. We have already discovered the connection between the Fibonacci sequence and the golden ratio. Let's review. So if you take two consecutive numbers and you take the larger one and divide it by the smaller one, you get a number that is approaching the golden ratio. So for example, when we divide 3 by 2, we get 1.5. The farther up the Fibonacci sequence you get closer and closer to the golden ratio. So we have 377 divided by 233, and we get 1.618025751, and so on. This is very close to the golden ratio, which is about 1.618, and so on and so on. Now you may ask, how can we use this to create a golden rectangle, which is satisfied when the rectangle is separated into two parts such that the longer side length divided by the smaller side length is equal to the sum of the two sections divided by the longer side length. So, in theory, this also means when the longer side length is divided by the shorter side length, we get a number that is close to or exactly the golden ratio, 1.618. Now we know that the golden ratio is connected with the Fibonacci sequence. So if we can create rectangles using the Fibonacci sequence, we will be approaching values that are close to the golden ratio. So let's take the first number in our Fibonacci sequence, which is 1. And we will construct a square that has the side lengths of a unit 1 by unit 1. Now let's look at the next number. It's also a 1. So let's create another square or rectangle that has those dimensions, 1 by 1. And we'll put it beside the first rectangle that we constructed. Now let's look at the next number, 2. So let's create a square that has the side lengths 2 and 2. And we'll line it up with the 1 by 1 rectangles there. Can you guess what we're going to do next? Create a square with the unit side lengths 3, and we'll place it beside. And so on and so on. We're just going to keep building and building on to this rectangle. So a 5 by 5 square and an 8 by 8 square. And now you can keep on going up the sequence with a 13 by 13 square, 21 by 21 square, and so on and so on. It will become more accurate, and you'll see as we go. So now we have a longer side length, as I said before, that is measured at 13, and a shorter side length that is measured at 8. Now we know that the relationship with the golden ratio and the Fibonacci sequence is as follows. When you take two consecutive numbers and you divide the bigger one by the smaller one, you get a number that is approaching the golden ratio. So when we take 13 and divide it by 8, we get 1.625, which is very close to the golden ratio, 1.618. Now, if we kept adding on squares and more squares that followed along with the Fibonacci sequence, we would get closer and closer to the golden ratio. Now, this is why this is a golden rectangle, because it satisfies the proportions. The longer side length is proportional to the smaller side length in the ratio 1.618. Now it is theorized that this rectangle is the most pleasing to look at for the human eye. So there are many architectural links with the golden rectangle. So here we see two very famous buildings, the Parthenon on the left and Notre Dame on the right side, and we can see how the golden rectangle is utilized in this architecture. There's more on this in the application section of the website, and you can look at how the golden ratio is applied to different architectural aspects.
We can also use the golden rectangle
to create something called the golden spiral. Now, this spiral is seen in nature, galaxies. We'll take a look at that in a bit. You can also look at that underneath the application section of the website. But the spiral is found in many things in nature, such as galaxies here, sunflowers, plants, the way hurricanes are formed, seashells. It's very, very prevalent in nature. So we can study those applications a little further. But that is how you construct a golden rectangle using the Fibonacci sequence.